Good day, everyone. This is me again, RENZ Angelo di Calzada, and my topic for this week in chemistry is all about the mole concept and Avogadros number. So before I begin with my discussion, this topic or this discussion will be tackling more about quantifying. But let's have an example first. In quantifying matter, we sometimes use terms that are readily associated with certain numbers. So for example, a dozen is 12, and an example for that is an egg. We buy eggs by the dozen, and we know that 1 dozen of egg is equivalent to 12 eggs. Another example is that we buy bond paper by the ream, and a ream of bond paper has 500 sheets. Another example is a case of soft drinks which has actually have 24 bottles. And the last example is a pair means two. Example for that is a pair of shoes and a pair of gloves. But in terms of but in terms of substances, how do we describe the amount of them? We are referring to atoms, molecules, compounds, ions, and the like. So how do we describe the amount of these substances? To describe the amount of these substances, we use the term mole. So what is a mole? When we say a mole, that is the amount that contains 6.02 times 10 raised to the 23rd power number of particles of a particular substance. So what does that particles mean? So what are these particles and what are these substances on that certain particle? So that those particles actually in a mole may be classified as molecules, they could be atoms, or they could be ions. So here, the particles in a mole may be molecules, atoms, or ions. For example, 1 mole of water or H2O molecules is equal to 6.02 times 10 raised to the 23rd power molecules of H2O or water. Another example, 1 mole of hydrogen atom is equal to 6.02 times 10 raised to the 23rd power hydrogen atoms. Another example, 1 mole of hydrogen ion is equal to 6.02 times 10 raised to the power of 23 ions of hydrogen or hydrogen ions. So as you have noticed, you can see that there is this number that keeps on repeating, and that is the 6.02 times 10 raised to the power of 23, and it seems to be constant, right? So what does that number means? Or what is its significance? Why is it always included when we talk about mole? So that number, actually, this unimaginably great number of particles in a mole of a substance is what we call the Avogadros number, which is equal to 6.02 times 10 raised to the power of 23. So saan nanggaling ang Avogadros number? So actually, it is named after Amadeo Avogadro. Avogadro is credited with the idea that the number of entities, which is usually atoms or molecules in a substance, is proportional to its physical mass. And Amadeo Avogadro first proposed that the volume of a gas at a given pressure and temperature is proportional to the number of atoms or molecules regardless of the type of gas. Although he did not determine the exact proportion, he is credited for the idea. And this Avogadros number is a proportion that relates molar mass on an atomic scale to physical mass on a human scale. And this Avogadros number is defined as the number of elementary particles. And what are these elementary particles? It could be molecules, atoms, compounds, and the like per mole of a substance. That's why it is equal to 6.022, or it could be 6.02 times 10 raised to the power of 23 per mole, or it could be written also as 6.02 times 10 raised to the power of 23 mole raised to the power of -1. And it is expressed as a symbol N sub A. So that is Avogadros number. So this time, let's talk about the mass of a mole. So the mass of a mole of a substance is numerically equal to the first, atomic weight of an atom of an element. Second, the molecular weight of a compound. The mass of one mole of a substance is called molar mass. So this time, let's talk more about on how we are going to get the mass of a mole. Let us begin with atoms. So for atoms, how are we going to get the mass of the mole? For example, we have 1 mole of lithium atom. Its molar mass, the molar mass of lithium atom, or 1 mole of lithium atom, is 7 grams per mole. Where did we get 7? That is actually equivalent to its atomic weight, which we can find in the periodic table. That is the atomic weight or the atomic mass of lithium. Therefore, 1 mole of lithium has a molar mass of 7 grams per mole. And 1 mole of lithium contains 6.022 times 10 raised to the power of 23 atoms. So, based on that notion, that could be represented as 1 mole of lithium is equal to 7 grams, and it is equal to 6.022 times 10 raised to the power of 23 lithium atoms. Let's have another example. Find the molar mass of zinc atom. So first step that we're going to do is to look for the atomic weight of zinc in the periodic table. Second, the mass of 1 mole of zinc is equal to its atomic weight. So if we're going to look at it on the periodic table, we will be finding there the atomic mass of zinc, which is equivalent to 65. And since we are talking about atomic weight, so it is equal to 65 grams. Therefore, 1 mole of zinc atom contains 65 grams. And 1 mole of zinc contains 6.022 times 10 raised to the power of 23 atoms. So therefore, that could be represented as, for zinc atom, or for 1 mole of zinc atom, that is 65 grams per mole, and it has 6.022 times 10 raised to the power of 23 atoms. So that is for atoms. Now let us proceed for molecules. For molecules, let's have an example. 1 mole of water, which has a chemical formula of H2O, it contains 2 hydrogen atoms and 1 oxygen atoms. So how are we going to get its molecular weight? So first, we are going to get the molecular weight, or we're going to get first the atomic weight. So that is hydrogen. There are 2 atoms of hydrogen times the atomic weight of hydrogen, which is 1. So that would be 2 times 1 is equal to. Next, for oxygen, we have 1 atom of oxygen times the atomic weight of oxygen, which is equal to 16. So that would be 1 times 16 is equal to 16. Then we're going to add 2 and 16. Then we get 18. So what is 18 now? That is the molecular weight of water, or H2O, which is equal to 18. Therefore, from that, the mass of 1 mole of H2O, or water, is 18 grams. 1 mole of H2O contains 6.022 times 10 raised to the power of 23 molecules. From that, we can say, or we can represent this as 1 mole of H2O is equal to 18 grams, and it is equal to 6.022 times 10 raised to the power of 23 molecules. Let's have another example for molecules. Let's say we're going to find the molar mass of carbon dioxide. First step, we need to determine the atoms present and the number of each atom. So for carbon dioxide, we have 1 atom of carbon and 2 atoms of oxygen. Second, find the atomic weight of each atom. So for carbon, we have 1 atom of carbon times the atomic weight of carbon, which is equal to 12. Therefore, we are going to multiply 1 times 12. So that is equal to 12. Next, for oxygen, we have 1 atom of oxygen times its atomic mass, or the atomic weight of oxygen, which is equal to 16. So we will have 2 times 16, that is equal to 32. Next thing that we're going to do, we are going to add 12 and 32, then we have 44 as its sum. So what is 44? That is the molecular weight of carbon dioxide. Therefore, from that, the mass of 1 mole of carbon dioxide is equal to 44 grams. And 1 mole of carbon dioxide contains 6.022 times 10 raised to the power of 23 molecules. So how are we going to represent that one? How are we going to represent 1 mole of carbon dioxide? So that would be 44 grams per mole, and that is also equal to 6.022 times 10 raised to the power of 23 molecules of carbon dioxide. So that would be all my report for the concept of mole, or the mole concept, and Avogadros number. Thank you so much for watching and listening. Here are my references. Thank you.